All right, so this is 3.3, properties of logarithms. You'll be able to apply properties of logarithms. So it's similar to properties of exponents. Okay, remember where you have two powers and their bases are the same, and you're multiplying them, then all you're really doing is you're adding them. This is the product property of exponents. And for quotient, the quotient property of exponents is when for powers that have the same base, okay, when the bases are the same, you just divide. When you're dividing, you subtract the exponents. And the power property is, remember, whenever you have that parenthesis separating them, it's kind of like a multiplication. So you want to distribute, all right, so that exponent on the outside is multiplied by the exponents on the inside. So here we have y times x. That's it. So when you multiply, you add. You divide, you subtract. When you have a parentheses, you distribute, you multiply. All right. Now, it's really similar to its inverse, which is logarithms. So the properties of logarithms are similar. The product property is where you have the log base b of two numbers that you're multiplying together is the log base b of x plus log base b of y. Okay, so it's like they're together and then you separate them. No. So here, the quotient property is where you have, when you're dividing two numbers, you want to subtract. And notice that they both have a log base b as well. And here, the power property, this one's a little different. Whenever you have a power, that exponent drops down to the front. Okay. So hopefully that made sense. When you multiply, you add. When you divide, you subtract. When you have a power, bring it to the front. That's how we get that. All right. I'm going to put that on the notes. Maybe I should type it. That might be better. You multiply, you add, you divide, subtract, and you have a power, the exponent in front of the log. All right, so that is the one that is different, that power property. Okay. Picture of that. All right, and here's an example. And this one is just showing the product property is true. All right, so you can look at that one. Oh, get rid of that. There you go. And there's an example if you want to look at that on the board as well, on the notes. All right, so let's look at these. It says express each logarithm in terms of natural log of 2 and natural log of 5. Remember, natural log is just the same thing as log. but with the base of E. All right. So here, we want to write all of these as natural log of 2 and natural log of 5. So you want to separate them each. So look at each of those numbers separately. So this 4, how can we write it as a 2 or as a 5? We can write that 4 as a 2 squared. And the 5 is just a 5. Okay, so watch this. We're going to break it down. I'll put it down here. All right. So it's like order of operations, except here you want to do, um, like it's like PEMDAS, except here it's you only have multiplication, division, uh, and powers. Okay, so you want to do the multiplication first, so product property, and then the quotient property. And then if you have any powers, PQP, PRQPO? I don't know. How about MQP? Okay. Well, just know that it's in that order. Okay, we don't have it, we're not multiplying anything. But here we do have a power and we do have division. So we want to get rid of we want to do the division first. So I think they want us to expand here. Yeah, they do. Okay. So we're going to do the division first. So we have natural log of 2 squared. And then the division becomes a minus. And this one also becomes natural log. So notice how that natural log goes to both of them, basically. The top and the bottom. Okay. And now we did our quotient. Now we're going to do our power. So here we have an exponent. So we bring it to the front and we get 2 natural log of 2 minus natural log of 5. And that is it. So you want to simplify it as much as possible. They don't say it, but that's what they're intending. All right. So over here, let's do, hmm, let's do 2. So natural log of 200. And 200, we want to write that as a 5 and a 2. Okay, how can we write that as a 5 and a 2? So you can do it this way. 200 is 2 times 10. Sorry, 2 times 100. 100 is 2 times 50. Let's do the factor tree. That's better. 50 is 2 times 25. 25 is 5 times 5. All right. So here we have 2 times 2 times 2. That's 3 2s and 2 5s. All right, so this is natural log of 2 cubed times 5 squared. And you want to follow the order of operations again. Okay, why don't you try number 3? Try 3. So follow the order of operations again. So we have multiplication first for this one. So that multiplication, we have the 2 cubed and that 5 squared. Remember, natural log, the log goes to both. That times becomes plus. Ta-da! And then we bring down those exponents to the front. So 3 times natural log of 2 plus 2 times natural log of 5. And that is that. All right, that's that. Um, and then for those decimals, uh, you want to know that 1/5 is going to give you 0.2. All right, because if you know that, um, then you basically have 1/5 times 4. All right, so you can think of it as 2 squared times 5 to the negative first power, all divided by 2. And these one of those 2's cancels out with the bottom one, bottom 2, and you're just left with 2 times 5. Just like that. Okay. So a lot of work. Just get familiar with those decimals. Um, do you see them often? You're gonna see it in chemistry. Okay, when you do take chemistry, you'll see those numbers quite a bit, but we won't deal too much with that. Well, we won't spend too much time with that here now. Okay, but that's what you want to think about when you think of those decimals, breaking it up into fractions. All right, and if you want, if you're if you try it and spend a lot of time, you have no idea. Yeah, the safest bet is to, if you want to do it like 12.5, just make it 125, and then you moved it one decimal place over. So you just put 1 0. So 125 divided by 10. And then you can simplify it that way. Okay. So you can do 5 goes into both 125, 5 goes into 125 5 times, 5 goes into 10 twice. There you go. Sorry, 25 times. 5 goes into 125 25 times. Okay. So make it bigger in order to make it smaller. Um, So let's look at another one. And if you want to try one of the decimals, just let me know. I'll do some. All right, that's that. And the next one I think is the same thing except with threes and seven. Same thing. Okay. Um, let's do one of those big ones. Why don't you try number 10. Okay. So you're gonna think about 49 is 7 to the what power, and then 81 is 3 to the what power. Okay, so do that first, but try to do number 10, similar to what we did in the last one. Um, and let me show you how to do one of these big ones. I showed you before the factor tree. Let's do it again. Why not? 13, 13, 23. I believe 3 goes into that. 4, 4, and 1. Oh boy. Does 3 go into that? 3, 1, 4, 7. Okay, I'm guessing this is going to be 3 to the some power. And you can do 3 again. 3 goes into 14, 4 times. Carry the 2, you get 9. Oh, almost there. 49 is 7 times 7. And that's it. Hey, so 13 is going to give us natural log of 1323 is natural log of 3 cubed times 7 squared. And do the order of operations. So do the multiplication. Handle the multiplication first. Natural log of 3 cubed, natural log of 7 squared, and make it a plus. When you multiply, you add. And then same thing, drop down the exponent. They have 2 natural times the natural log of 3 plus 2 times, oh, sorry, that's a 3. The 3 over there. Me and my handwriting. Okay. Plus 2 times natural log of 7. And that's it. All right. I guess let's do one with a fraction. This one looks, no, I'm just kidding. Uh, why did I choose a big one? Oh, no. Okay. That's fine. I guess I'll do 14. 343 and 729. Let's do both of these. 343 is breaking up to 3. Nope. Okay. It's a nope because 3 goes into 3 once, and then 3 goes into 4 once. We carry the 1 and get 13. 3 does not go into 13, so let's try 7. 7 goes into 34. It's going to give us, it's almost 5, so it's going to be 4 times. So 34 minus 28 is going to give us 6. And so 63. 63 divided by 7 is 9. And there we go. 7 times 7. Ta-da! And 729, let's try 3. 3 goes into 7 twice, carry the 1, 4, And 3 goes into 9, 3 times 24 again, 243. There you go. 3 goes into that. 81 times, and 81 is 3 cubed. Sorry, 3 to the 4th. Oops, what am I doing? All right, there you go. It's a lot of threes. Okay, so 1, 2, 3, 4, 5, 6. I have 14 natural log, uh, 7 cubed over 3. Did I say 6? Okay, so do the division first, the quotient. So it becomes natural log of 7 cubed, natural log of 3, 6. And the numerator, the top part always goes in front. Okay, the denominators, whatever is in the denominator, that's going to be minus. Whatever is in the bottom, it's going to be minus. Okay, that's the one that we're subtracting. And if you're wondering, well, Mr. T, what if there's 2 things in the bottom? Yeah, you're going to see 2 things in the bottom. They'll both be minus. All right, and then bring down the exponents. You get 3 natural log of 7 minus 6 natural log of 3. Yay, that was fun. All right, so try 10. It's a good one. If you want to try 9, feel free to try 9 as well. All right, and there we have Juice Burgi, a Swiss mathematician. All right, so we have simplifying logarithms. All right, now if you have a radical, if you have here it says evaluate each logarithm. We'll do one of these. So if you, okay, so if you have a radical, then you need to think of that as a fraction. Remember, square root of x is just x squared to the 1/2 power. Because there's an invisible 2 here, right? Cube root of x is x to the 1/3 power. Fourth root of x is x to the 1/4 power. So that, got what it was called, that number in the front, okay, that root, that nth root is going to be your denominator. Okay, and the same thing applies here. So look at 26. And if you want to try number 19, feel free to. All right, 26, here we go. And this is going to be the last one for today. So 50 times log base 5 of, and I'm going to write this radical as a 1/2 power. And I'm going to write 125. Now that 125, that radicand, can be changed. Oh no, got that joke. That radicand can be changed to 5 cubed. All right, there we go. And then that, okay, the power property of exponents, 3 times 1/2, is going to give us, yeah, this stuff doesn't change. It's going to give us 3/2. Now the power property of logs, we bring that power to the front. That becomes 50 times 3/2 times log base 5 of 5. And log base 5 of 5, hey, when the base is the same as the number, it's just a 1. We have basically 50 times 3/2, which is 50 divided by 2 is 25, times 3 is 75. And that's it. All right. So yeah, try number 19. Um, I think that's good. Yeah, you might get a fraction for that one, but that's okay. Not that bad of a fraction. All right, we're going to stop there. Let me stop this recording.